Welcome to episode 234 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing all right, Rob. How are you doing?
I'm doing just fine. Don't have too much news to discuss. You got any updates or announcements?
No, nothing new. I mean, we mentioned the class that I'm going to be doing in Stuttgart.
You got much interest in that yet?
Apparently a few students have already signed up for it, yeah.
Awesome.
Sorry, not late August. That's late September. I have a different thing in late August. That is not ready to be announced yet. No, not yet.
Okay. Well, at the top of every sort of lecture piece of feedback, this week we got this tweet from Viktor Zverevich, who is the one who put out the C++ freestyle rap video, which we discussed last week. And he just sent out this tweet when some people were talking about it, saying, I very much hope that John Lakos expresses his response in the form of a freestyle rap. John definitely enjoyed the video, but unfortunately did not respond with his own freestyle rap, although I wouldn't be surprised if he's capable of one.
Yeah, I mean, who knows, really?
Yeah. He seems like a very capable guy. Who knows what else he can do.
I would not personally, do my own freestyle rap, I don't think.
I definitely don't think I could do that, yeah.
No.
Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Brad Larson. Brad started programming in BASIC when he was 9, primarily on the Apple IIe, transitioning to QBasic in high school. He graduated from Kansas State University in 2005 with a BS in computer science and a minor in embedded systems. While at K-State, he enjoyed working on the solar car racing team, which built and raced a vehicle across the U.S. and Canada. After graduating in 2005, Brad started working at Garmin, where he worked on a variety of products, including Palm PDAs, Brew phone platforms, Android, iOS, and automotive devices. He currently leads a team focused on bike computers and fitness watches. In his free time, Brad enjoys working on home improvement projects, spending time with his wife and their 5 kids, and hobby programming. Brad, welcome to the show.
Hi, thanks so much. I'm really excited to be here.
Brad, I feel like something in your timeline doesn't quite add up. Because if you graduated in 2005, that makes you about 5 years younger than I am. So I'm surprised that you started programming on an Apple IIe.
Well, I was trying to think. Yeah, I think it was an Apple IIe. We had a few in grade school, and they eventually picked up. I figured out how to get into BASIC on them, and I thought it was a IIe, but I don't know. That was so long ago. I could be misremembering.
Oh no, very well may have been. Those things stayed in schools for ever.
Yeah.
But let's say a 2GS in 6th grade was the fanciest Apple II series that I ever saw in a school. Yeah, I think that was 6th grade.
Yeah.
For me. So, I mean, it was presumably already a relatively old system anyhow when you were programming.
It probably was, yeah. And I think I found a few books at the public library that talked about BASIC on them, and just kind of went from there.
Just for the record, I wasn't trying to say that you had made up a story here. I was just trying to get the deeper story.
I don't think there's too much extra to it. Yeah. Just some basic programming on apples.
Okay.
Well, Brad, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about what you're doing at Garmin, okay?
Great.
Okay, so this first one, we have a developer ecosystem survey from JetBrains. We've talked about these before and talked about the results, which are always interesting. So I definitely would encourage anyone listening to go and click on the link and go through the survey. One thing which I don't recall seeing before is that they are doing some raffle prizes with the survey. So it's worth pointing out. You can win a MacBook Pro $300 Amazon gift card, or a JetBrains surprise gift pack. Not sure what that is, but sure
it might be
exciting.
JetBrains products.
It might. But I mean, those are 3 great prizes.
Oh yeah, one of those is worth considerably more than the other 2. I'm guessing.
Yeah. MacBook Pro is.
Those start at like $35,000 or something, right? I'm sorry, I just don't know Apple prices very well.
I don't know either, but I would believe that.
$100.
How much did you say, Brad?
$3,500 maybe.
Oh, $3,500. That's off by an order of magnitude. My mistake.
So yeah, it only takes about 20 minutes to do the survey, and we'll put the link in the show notes so you can definitely go take a look. Next thing we have is from Bartek's coding blog, and this is 5 awesome C++ papers from the Prague ISO meeting and C++ 20 status. And the Prague meeting is going on right now. I don't think we will hear any news from it until the meeting is over.
Right.
But this highlights a couple papers that are, being presented. We're in the mailing. There's one we kind of talked about recently, which is "Don't Context for All the Things," which is a paper that references Circle a lot, which we talked a lot about, I think 3 episodes ago.
Yeah, that sounds right.
Yeah. Were there any other papers from these 5 you wanted to highlight, Jason?
For me, I mean, well, I could say something about just about every one of them because there are things that I wasn't aware of.
Okay.
The heterogeneous erasure overloads for associative containers. I mean, just the is transparent and heterogeneous key lookup stuff for associative containers, which basically allows you to say if you've got a container of strings, you can pass in a const character pointer without having to first create a string of that, and it can have significant performance impact. It's interesting to me that they want to add the same set of overloads to erase. And then I find this guaranteed copy elision for named returned objects interesting. I'm going to have to actually read the paper on that because there has to be at least 5 caveats to say exactly what situations where this would occur.
Right.
I thought that was interesting too because we've had a lot of discussions about should we rely on copy elision in some of these cases or not, and should we have our coding standard permit or encourage just returning your object and rely on copy elision or what the best option is, and NVRO was kind of the biggest wrinkle in all of that.
Yeah, I mean, I will just say for the sake of the record here on the show, if you limit the scope of the object that you are returning as much as possible, then you're almost guaranteed return value optimization. If you have a bunch of objects in scope and you're trying to decide which one to return, then you're not going to get it. Mm-hmm. So.
Right. And just to mention the other 2, one of them is debugging C++ coroutines, and I haven't read the actual paper, but it sounds like someone went through and implemented, I think, a WebSocket server using coroutines and just talked about the difficulties with debugging their code and is putting some recommendations for compiler vendors to make debugging easier.
That sounds important.
Yeah, it does. Definitely does. And then the last one was mitigating Spectre attacks in C++.
Yes.
Yeah, which is definitely important. And one solution that's mentioned here is that we could maybe add C++ attributes. We're seeing lots of new attributes being added to the language, and that attribute could be translated into something like offense because the different compilers, I think, implement those differently.
Yeah.
Yeah.
I don't know how I feel about an attribute that is speculative load hardening true because it just seems very wordy, but I guess it probably makes sense for at least some areas.
Yeah. Anything else you wanted to mention, Brad?
I do feel the pain of, I haven't worked with coroutines, but I feel this author's pain that sometimes these new features are really tricky to debug, and we might get into it later, but we've ran into problems with lambdas that everything, at first blush might look correct, but then you realize you're capturing something by reference that goes out of scope, and it's been painful for us at times to debug some features like that, and just waiting for debug tools to kind of catch up, and so yeah, I feel this pain.
Yeah. Okay, and then the last thing we have is an announcement from the Core CPP conference in Israel. And this is that they're thrilled to announce that their first keynote speaker for Core C++ 2020 will be Bjarne Strustrup. So
yeah.
It's very exciting.
Pretty big news for a relatively small conference.
Yeah, definitely. And again, this is early bird tickets are open February 15th. And do we know what the date is offhand?
For the
May
conference?
25th. Yeah.
Yeah.
Conference is May 25th, 27th. Yep.
Yes, it's exactly over my anniversary. I will not be going to Core C++ this year.
Right. Okay, so Brad, we talked a little bit about the type of work you do at Garmin. What types of devices are you working on today?
Yeah, so I'm on the fitness team, and on fitness we have two main categories of devices. One is watches, which is smart watches or fitness watches, triathlete watches, things like that, and the other is bike computers. And for Garmin, that's our Edge line is
Yeah.
the product line.
For
And
those who are listening, Brad actually just showed us these on the camera if you
yeah,
happen to go to the YouTube to watch it.
yeah, that's not helpful for the 99% of your viewers or audience that
Listeners, yeah.
listens to
Yeah.
the podcast. But yeah, I held them up real quick. But yeah, so those are the two main product categories. My team focuses mostly on the watches, but we help out with the bike computers as well. And yeah, lots of features that we try to fit into as small of a space as possible, from lots of GPS tracking, recording your speed and distance and position and stuff like that when you're out for a jog or a walk or bike ride, things like that. We do smart notifications over Bluetooth, BLE. We talk to a lot of wireless sensors over a different protocol called ANT, which is very similar to BLE. So we can talk to a wireless heart rate strap if optical heart rate on your wrist isn't accurate enough. We talk to wireless power meters on your bike or foot pods you can attach to your shoe to kind of get an accurate, if you're running on a treadmill or something like that, we can still get pretty accurate distances and step counts and things. So yeah, lots of fun, interesting challenges.
So all of those things talk to the devices you just described, either the watch or the trip computer.
Yep. The watch or the bike computer, it's got a file system on there, so it records all that data, stores it to the file system. When you're done with your activity, Garmin has a website called Garmin Connect where you can upload those files to. You can attach it through USB. You can sync it over Bluetooth to your phone. Some devices have built-in Wi-Fi, so they can sync it over Wi-Fi standalone up to our website. And on the website, then you can see a map of where you went. You can see graphs of your elevation over time, your heart rate over time, all sorts of stuff like that. You can be social and share it with your friends, or if you have a running coach or things like that, you can share your activities and get feedback and stuff like that.
So just out of curiosity, do any of these devices have cellular antennas as well, since you mentioned Wi-Fi and Bluetooth?
Yeah, good question. We do have one device out now, the Vivo Active 3, which is it's not focused as much on fitness. It's more of a smartwatch category, but it does certainly support a lot of the fitness features we do, and it has a variant of that does do LTE. Yes.
That's fascinating to me. I mean, was the future, and now it's normal.
Yeah. The future is now. Yeah.
I still don't have a flying car, though. I just have to say.
No, I don't think Garmin's going to make those.
Yeah, that's not our market.
What does software look like on the watch? I mean, are you basing this on a Linux system or Android, or is it a custom OS, or is it a pure embedded system?
Yeah, good question. We are full custom.
Okay.
Especially on the watch side, they are such. It's always a trade-off. We really want a small watch, small form factor. We want great battery life, and those and then we see what performance we can get out of the platform that we're given. And so we do a full custom OS, and OS is almost stretching it because it doesn't support multiple processes. It does threading and memory management and stuff like that, but it doesn't support multi-process type stuff. But that's what's necessary. And so yeah, we've got most of our code base is still in C. So a lot of our OS libraries and things like that, they're all written in C, or GPS code and file system code, stuff like that. But more recently, the past few years, we've been experimenting and pushing really hard to change out our UI framework that sits on top of everything to be C++. And that's gone really well. And so what an interesting thing that kind of helped us kick it off is actually Jason did a talk on running C++ 17 on the Commodore 64, which hopefully most of your listeners have heard that talk by now, but if not, you should definitely go check that out. But that was a really fun talk because that was right as I was working on getting C++ stuff running on a watch, and as he was going, Jason kept having kind of side discussions on, now, memory on desktop, you got plenty of memory, but on the Commodore 64, you only have, what was it, 256K of RAM or something like that.
64K.
64K. So I was like, well, gosh, our platform only has 256K of memory. And then later on, you're talking about colors, and you're like, no, on the Commodore 64, there's only 16 colors. And well, on our watch, there's only 16 colors. And so it was neat. There's so many parallels, and yeah, you still had very good luck running lots of advanced C++ 17 features on a very low-end platform, and so yeah, it was fun to watch that as we were trying to solve some of the same problems.
So you did just tell us like 256 color or 16 colors, 256K of RAM. Are there other details that you are allowed to tell us anyhow about what the hardware is on these things?
Sure. Yeah. And so those numbers are somewhat dated. Those were from the watch I was working on. When you were giving that talk. So.
Okay.
So since then we do have. I don't know if I can say the numbers. We have more memory available now. We've started to put onboard maps on some of the higher end watches.
Oh, wow.
And also we do music. We'll stream music on the higher end watches, and so those two features require a fair amount more RAM. So we're into the, I think, single digit megabytes now of RAM. Yeah, it's a whole new world. And on the ROM size, we're in the also the single digit megabytes of ROM. And so. Other than that, I don't know if there's any other statistics you'd be curious about.
Can you tell us what architecture it is?
Yeah. So it's all ARM stuff. The watches are a Cortex-M series processor, and those run just thumb instructions. So it's a pretty small subset of ARM.
Oh, it's a thumb-only processor.
Yeah.
Interesting.
I believe, I don't know. I might be wrong on some of the details there, but I believe Cortex-M is thumb only.
That sounds believable, but I haven't spent a lot of time with that.
Yeah, I don't. I work mostly on the UI side of things, and so I would have to reference one of the device driver engineers that we work with. But yeah, on the bike computer side, there's not as many trade-offs. They can fit much beefier processors with much more memory and stuff like that on those. So it's more the watch side that we're very limited, and we have to get pretty creative on how to cram features in with a very small amount of memory.
And so you're managing Bluetooth receiver, you said, Wi-Fi in some devices, GPS, heart rate monitor.
Mm-hmm. Yeah.
What else? Step counter?
Yeah, lots of, yeah. We do onboard step counting. We do, on wrist heart rate. We can talk to lots of different wireless sensors in the ANT ecosystem. So there's, power meters. There's a neat, you can get some glasses that have a display built into them, so you can, if you didn't want to look down at your watch, you can look at the, what's being displayed on those glasses. Step counter that you can put in your shoe.
Wait.
Temperature sensors and all sorts of stuff, yeah.
I can have glasses that talk to my watch and show me what's on the watch currently, so I don't even have to look at the watch?
Exactly, yep.
Okay.
Interesting.
Might have to add something to my Christmas list here.
Yeah.
We'll see.
Yeah.
One question I have is, does your team make all the apps that go on the watch, or is there a SDK for third-party developers?
Yeah, so starting a few, 3 or 4 years ago, Garmin did announce an SDK. So it's called Connect IQ. We do allow third-party developers to write different types of content for our watches and for our edge bike computers. 4 main types of apps you can do: watch faces, widgets, which just kind of give you information at a glance, like sports scores or stock prices or things like that. Full apps. So if at that point you take full control of the device and you can react to any button press and do whatever you want to as an app. And then the last one is data fields, which are popular when you're going out for a jog or on a bike ride. Most of your interaction with the watch is looking at a screen of data fields, and so you might have 2 to 4 data fields on a page, and one of the ones that third-party developers have really flourished with is creating their own custom data fields. And so it can be as simple as a hello world type example is you can have a data field that shows you how many cookies you've burned off or things like that as you're on your jog, to very complicated data fields that are talking to proprietary wireless sensors or things of that nature. So yeah, that's been a very successful third-party SDK for Garmin that users have really embraced and leveraged.
Okay, and I think you said that you work on the UI side, and it's a C++ UI widget tool. Is that what SDK developers use too? Are they writing everything in C++?
Yeah, yeah. It's actually not. So we considered a lot of options for how can we get third-party content, third-party software onto our watches. C or C++ would be nice. The biggest problem we have with those is with I mentioned earlier our OS situation that it's a very bare bones, bare metal OS. It would be very difficult for us to sandbox those third-party apps.
Oh yeah.
Okay.
And so if someone did something as innocent as a divide by zero, that even preventing that from shutting down the watch, that would be solvable. But we certainly don't have the concept of like a user space versus kernel space or things like that. And so for those reasons, C and C++ just did not seem very feasible. And so we looked at some other options. Python or scripting languages just use way too much memory for a device that's got 256K of RAM. That's not a good option at all.
Right.
And the other popular option that might have worked was Java, but we kind of scuttled that because of the legal situation that Java's in. If you look at Google and Android and and Oracle and stuff, that it just didn't seem like something we wanted to mess with. Is a little too risky. So instead we went with just writing our own language, our own virtual machine, our own compiler, the whole stack. And
wow.
It was a lot to bite off at first. I wasn't involved with any of that effort, so I can't claim any credit. But a friend of mine at work, started writing his own compiler and virtual machine, and a few months later we could run custom content on our watches and not use much memory at all. And so yeah, we've got a language called Monkey C, and it's not that different from like a Java or Python or C++ syntax, and it's not too hard to pick up and start writing content.
Okay.
It's a funny pun built in there, I guess.
Yeah. That team is very pun friendly, I guess. They got Monkey C as the language, and then at one point the compiler might have been called Monkey Do.
I would imagine.
Yeah. No, there's lots of fun pun opportunities when you have your language like that. Yeah.
So you mentioned that you've been involved directly in the move from C to C++ for the UI. What has that experience been like?
It's been overall we've been very happy. If we just look at kind of there's two sides to that question, I guess, the technical side and then the engineer side or the person side on reception. But focusing more on the technical side, it's gone really well. Modern C++ has made this probably feasible in general. I don't know that we could have pulled this off with C++ 03 or not. It would have been a much more difficult challenge. ConstExpr especially has been really helpful. And so I don't know, the way we leverage that there is stealing some ideas from iOS and Android development. We can specify page layouts in XML with our system, and then we have a compile time tool that goes through and takes those XML layouts and converts them into C++ code that just get compiled in. And so that works really well. The pages get converted into ConstExpr structs, which is important for us because we don't have much memory, so we need everything to live in ROM as possible. And so the fact that we can compile those down into ConstExpr structs that are guaranteed to live in RAM or in ROM and not go into RAM at all, that's been really helpful. And then also the fact that now we can call functions and stuff in our XML layouts. You could say, hey, the X position of this equals, do some math, because on a round display, sometimes you need to do some math, some trigonometry and stuff to find the best X position or X, Y position and stuff. So we can put stuff in there, and then it as long as it's ConstExpr functions, then it gets handled at compile time, and it it's just a binary number that ends up in that struct.
Nice.
And then if it's not a ConstExpr function, then we get a compile time error that says, this is not going to work as a ConstExpr struct. You need to go, find a way to do this at compile time. So that's been good. Also, smart pointers have been really helpful. We use unique pointer everywhere. We've seen our stability go up somewhat, and I think smart pointers have actually been a fair amount of that.
I'm actually kind of surprised you're allowed to do dynamic allocations.
Yeah. We're kind of careful about it, but yeah, we certainly have malloc and new and all up the stack. Yeah.
Okay, that leads me to another interesting question because generally the answer is that it's basically impossible to handle an out-of-memory error. But do you handle out-of-memory errors? How does that work?
No. We reset the watch.
Okay.
It frees up a lot of memory. No, we don't handle out of memory. I mean, we do have a few cases where we can say, hey, malloc some memory, and then let me know if there's not enough available, and if we're wanting to do buffers for specific situations, we can gracefully fail. But in general, no, we have not taken the time to add null checks to all of our malloc returns and stuff like that. No.
Yeah, so sorry to interrupt you. You were saying unique pointers you think have helped the stability of the watch a lot.
Yeah, unique pointers have helped the stability quite a bit. Other than that, yeah, basic UI, getting a basic UI up and running with object-oriented language is a lot easier than you might think. So we've got our page stack is just a vector of base page objects, and each page object, it just has a vector of, we call them widgets or fields or views or whatever your UI framework wants to call them. But yeah, those just go into a widget. And you've just got a base widget class, and it's got a x, a y, a width, and a height, and some basic methods on it, and then you can just kind of extend it from there. And I can almost hear Sean Perrin yelling that no, inheritance is the base class of evil and stuff. But and he's got good points about that. But it worked really well for our needs, and it got us up and running pretty quickly. And when you start to do the more finer details of how do you handle touch inputs and page transition animations and stuff like that, there are more difficult wrinkles you have to work out and stuff. But overall, you can get up and running pretty quickly with an object-oriented language like C++ for UI frameworks.
And you said as much as possible is calculated at compile time.
Yeah, that's very important to us. You can still at runtime change the position of a widget or things like that, or resize widgets on the page and stuff. So you can still call setters and stuff, but by default, it all just lives in ROM, and a widget on a page takes up 4 bytes or something like that of actual RAM space.
Wow. Basically a pointer.
Just a pointer to that ROM, and then if you need to call setters, then we can move it into RAM and start changing values. But for most of our UI layouts anyways, things are pretty static. We show data, but we don't move it around and resize that data and stuff too much. And so that's worked out really well for us to avoid taking any RAM usage that we can avoid.
Have you been able to quantify that, and have you seen smaller binary sizes or anything moving to C++ with these techniques?
Yeah, it turns out measuring that stuff is really tricky, especially the RAM usage stuff. So, and it's also hard to be apples to apples, because the UI framework I'm comparing it to was our C UI framework, which is a good UI framework, and it's probably the same UI framework you or I would have written if we wrote a C UI framework from scratch in the early 90s or so. I think understandings of how to write good UI frameworks have changed a lot since then, or have improved. So comparing it to our previous UI framework, we are seeing less allocations and less need for memory allocations in general. But potentially if we started from scratch with a C UI framework, maybe you could do as good or close to as good. It's hard to know.
Right.
On the ROM side, similarly, yeah, we're in the same ballpark. Sometimes we're a little bit smaller on ROM for a particular page implementation. Sometimes we're a little bit bigger, but it's all been the same ballpark. So we've been very happy. The main reason we wanted to switch to C++ was really just to get rid of boilerplate. With our C UI framework, if you wanted to make a blank page, just as a starting point, a blank page alone was, I think, about 350 lines of code or so, something like that. And so now you can just, you can extend a base page object, and that's all you need for a blank page, and it's like, 5 lines of code or something. So we've definitely succeeded in improving boilerplate. And after that, if our RAM and ROM was at least ballpark the same, then we were satisfied. And we definitely are ballpark the same. And in some cases, we're significantly better.
So it sounds like you are then using some virtual function call in your interfaces.
Oh yeah, we use virtual tables and stuff quite a bit. Yeah.
Okay.
Yeah, and that hasn't been a problem. Hasn't slowed us down anything. The one modern C++ feature that's been a little bit tricky has been a std function. So we use lambdas a fair amount, which are great, and we've got an API that will say, hey, run this lambda in 3 seconds or something like that, or run this lambda every 1 second, and then that might go, check your distance and update the data field that shows your distance or something like that, which has been really helpful. But the fact that we then have to store those lambdas as std functions, that has been pretty heavy on the ROM side. So every time we have a std function that we store, it takes up, I don't know, close to a K of ROM, like that. And which, if you're doing desktop work, you're probably laughing and saying, a K of ROM, who cares? But no, when we're on a small embedded device, that can add up pretty quick. And so we still use std functions where they make sense, or store lambdas as std functions. Other times we'll say, our use cases here are sufficient that we can just store a function pointer instead of a std function. We don't need to worry about capturing or things like that. So
you take advantage of the implicit conversion from lambda to a function pointer capability.
Yeah, we might do that at times. Yeah, or other times we just have to have a static function somewhere that we pass in as the callback.
So now I'm curious because I have showing examples of std function in my classes and talks and something is something I do often, and I've noticed that the compilers keep getting better and better. So like 2 years ago, I could avoid function C, and I put a slide up, and it's got 10,000 instructions generated. And today, it's not surprising if the compilers can see completely through that and completely eliminate the virtual functions and the small object optimization and everything, and it all just goes away. So what compilers are you able to use, and are you on an upward path, I guess, to being able to upgrade your compiler?
Yeah, we definitely have been, I can't take credit, but the low-level engineers that maintain our compiler and stuff have done a very good job of keeping us up to date. So we use GCC for our hardware builds, and then we also have a Windows simulator, and that's Visual Studio. And so we're up to Visual Studio 2017 right now, and we'll probably upgrade to 2019 or sometime in the next year. And then GCC, I should know which version we're on, but we upgraded to close to tips of GCC a year or two ago.
Okay.
And that's a good
Probably
point. That
7.
It probably is. 7 sounds right. I'm sorry. I wish I knew better.
That's all right.
But yeah. So yeah, that is a good point though. That my statistics for how expensive std function is, those are a few years old, and that's probably more on GCC 6. And so yeah, that could be improved by now. I should actually go back and double check that.
Maybe, but if you have code that works that's using the function pointer conversions or whatever, it's still an extra layer of indirection that you're not using if you don't have standard function in there.
Absolutely, yeah.
Sorry if you already said this, but what version of C++ are you currently able to use?
Yeah. So right now we're targeting C++ 14.
14, okay.
And we'd like to, or personally, I'd like to start using some features in 17. And I tried to turn on 17 a couple weeks ago, and evidently with some of our mid-level code that I never touch was still using a std auto pointer, which is now removed in 17. So I'm like, oh man, I got to go back and fix that, and which wouldn't normally be that difficult, but I want to change it to be a unique pointer. But we've got some other products, not in the fitness space, but in other departments at Garmin. They're not compiling with C++ 11 yet. And so it's kind of finding the right balance. So I think we finally negotiated that they would change it to a boost smart pointer for now, and we'll work around it that way. And then at least I can upgrade my stuff to be C++ 17 and start using some of the new features we're excited about.
Yeah, don't tell anyone else this, but every compiler does have a pound define that you can give to re-enable auto pointer in C++17 mode.
That's a good point. I hadn't really thought about that, but I don't know. I just personally, I feel a lot better just getting rid of that auto pointer.
I agree, yes, but I would just say from my experience of interacting with people doing embedded devices, I'm impressed that you are staying on top of compilers and moving forward with things. You don't tend to see that very often.
Yeah. It's sometimes it's an uphill struggle. Just that the biggest problem is that we've still got the teams that are stuck pre C++11. They're using compilers that haven't been updated ever. But they've got assembly to do device driver stuff that only works with that compiler, and so that was something the fitness team went through a while ago. Is we had a lot of our device driver stuff that was in assembly had to be rewritten to work with GCC's assembly for syntax.
Right.
So that's the biggest pain point we have right now is some device drivers that are in assembly that have to be rewritten from scratch, basically, or not necessarily from scratch, but rewritten to support the different syntax from a different compiler.
Now, might be going a little off topic here, but you said that your UI framework, the C version of it, was state of the art in the 90s, effectively. Is this the UI framework that you're working on? Does it have its history in the old standalone Garmin GPS that I have in my parts bin there? Yeah. That's from year 2000?
Yeah. Those probably are very similar UI frameworks, and it would be the same operating system, C code base, and the same GPS interfaces and stuff like that. Yeah, Garmin does a very good job at sharing code across a very diverse set of products, and it's been very helpful, generally helpful. Sometimes there's always pain points with that, but it's worked out very well for us.
Wow, that's cool.
Yeah.
That actually reminds me, Rob, I think in one of the very early episodes of CppCast, you mentioned that you used to work for a Navigon, one of our competitors. Is that
not Navigon? I used to work for a company called ALK, which makes Copilot, which is another navigation software.
Okay.
Yeah.
Okay. It was so long ago, I guess I got confused, but yeah, that's cool. Yeah.
Go ahead, Jason.
Well, I was going to ask if there's any. You said std function has been a pain point for you, but are there any core language features that you can't use for whatever reason?
Nothing I've ran across, nothing I'm aware of right off. As I mentioned at the start, we have at times we've really struggled with some bugs inside of lambdas that have just been really tough to debug.
Right.
So yeah, and that's that same interface I mentioned where, and we use it a lot to say, hey, go run this every second or something like that, run this lambda, and if that lambda happens to capture something by reference that then goes out of scope, it's really tricky to debug those situations. Visual Studio is actually pretty decent at helping us debug them. So if we can reproduce the bug in our simulator, then that's okay. But if it's on hardware with a JTAG debugger and stuff, it's been kind of tricky to figure out how did we get off in the weeds and what's going on and stuff. And that's just kind of been a learning experience. We've gotten a lot better at looking for those sorts of things in code review and stuff, and so it hasn't been terrible, but for a period of time that was causing us quite a bit of headaches. That we had a product that was needing to go out, and we ended up finding at least 2 or 3 of those types of situations that were causing some crashes that were really tricky to track down.
An Argument Pro moving to Visual Studio 2019 is what we covered this on the channel a few weeks ago. Visual Studio 2019 now has address sanitizer support and could help make tracking down those things a lot easier as well.
Yeah, that's a good point. Yeah, and I've also been meaning to look into if there's any other static code analysis tools that would catch that sort of thing. I wasn't aware of Visual Studio 2019 doing it, but that's good to hear.
Yeah. Clang Tidy will catch some of them today. It's still not great at it.
Yeah, and we do use Clang Tidy some, and Clang Tidy's been great. I was kind of frustrated that Clang Tidy now, I just upgraded Clang Tidy, or our team did, and it recommends we convert all of our functions to use the trailing return type.
I just disabled that, yeah.
Which we did just disable that. I'm like, oh, that can't be good advice, can it? I mean, does anyone really think that you should go through and change all your functions to a trailing return type? I don't know. I'm not sold.
Yeah, and I will like every other function signature I write. Sometimes I'll use trailing and sometimes I won't. That's the worst of both worlds. So you should probably pick a style. But
Yeah, yeah. I don't know that, and that kind of goes to the other aspect of how is switching over to C++ gone, which is the human aspect, and it's gone pretty well, but we've definitely struggled at times with the language is just getting more and more complicated, and trailing return types is a small example, but
hmm,
it's hard to keep up, especially for you know C engineers that have just been doing C programming for
Right.
10, 15, 20 years. Modern C++ is great, but I don't know. I'm hopeful that Herb will have luck in his goal to simplify the language. I think it's becoming more and more needed, and so.
right.
Is there anything in particular you're looking forward to? I mean, I know you need to resolve the auto pointer situation and get up to C++ 17, but is there
Yeah.
anything you're looking forward to with 20?
20, I don't. That's a good question. I haven't followed coroutines close enough to see if that's something I could really leverage too much or not, or same with modules. So I need to go back and watch a couple more presentations on those to see where things are at. On 17, I know it's a small thing, but I'm excited to switch to std optional because right now we got some code that uses boost optional, and just anytime I can switch, nothing against boost, but anytime I can switch to stuff that's built into the standard, then that always gives me some warm fuzzies. Um, I don't know. Also at 17, I'm it's silly, but I'm excited for what do they even call it? The nested namespaces, or the listing
Oh,
out
yeah.
namespaces
In some
all on one
cases,
line.
nested namespaces can yes, it can be very helpful. Yeah.
Yeah, yeah. So I'm excited for that, and I mean our coding guidelines right now say that inside of a namespace they want us to tab in, and so that really discourages doing too much nesting of namespaces. So once we can put all those on one line, that'll clean that up quite a bit and make people more willing to nest namespaces as deep as they want to.
The only problem then is the white space diffs when you're ready to push it all back up to source
Yeah,
control.
yeah, yeah. But hopefully it's just a one time, one commit, one painful commit type thing, and we'll
Yeah.
be all good. I don't know. Yeah.
Are you able to use exceptions, or do you?
Yeah, that's a good question. We do compile with exception support, but
Oh,
we
fascinating.
and more recently, I have found some places where RTTI has been really helpful,
Okay.
but we don't actually throw or catch any exceptions at this point. So RTTI and exceptions, we saw about a 10% increase in our ROM size on the subsection of our code that's C++. And for some of the potential benefits, we figured 10% was an acceptable trade-off.
Okay.
And again, I'm really excited for Herb's work on making exceptions significantly
Static
lighter weight,
Yeah.
yeah, static exceptions. So that's just it's really exciting. So I hope that I don't know. I was joking with some coworkers that that's going to be so far off, but I'm going to go buy a digital countdown clock for our hallway. You know, exceptions will be 9 years until exceptions are really cool to fun to use and stuff. So,
It
but
could be.
yeah, I don't know. I'm excited for the future there. It's a very exciting time to be working in C++, and especially Herb's recent keynote was hitting on all the points that we struggle with on language complexity and exceptions and RTTI being expensive and stuff. So yeah, we do compile with exceptions, but we haven't really found a place that really needs them. In the future, I'm hopeful that more of our mid-level code will also consider switching to C++ and rewriting their current C stuff as C++, and people have expressed some interest there as well. And there, I think it makes more sense to use exceptions. That's where you might have more exceptional situations of, the Bluetooth connection was dropped or something like that. When we're doing most UI stuff, there's not a lot of things that have in my mind been exceptional where we would need to throw an exception.
Right.
I think that comes in more in the mid-level code where, if we have file system errors or things like that, then exceptions make more sense.
I think it's most interesting, maybe from the point of our listeners, I would think that you don't just systematically disable them because you have calculated that the small price that you pay is worth it for what features you are getting currently.
Yeah, yeah, and RTTI especially recently we've added some debugging tools that in our simulator you can open up a window and it'll give you a dump of the full page stack, and which is cool. But then also we can tell you the class name of every page on the page stack, which is super helpful on, I don't have to go and add, text names to every page to get that debug output. I can just use the RTTI to get the type ID name field, and it's it's not as amazing as some of the features that we're looking at for C++ 20 and 23 and stuff, but some basic information about class names and stuff like that.
That's cool.
Yeah. Might want to go back to something that was mentioned in your bio for a minute. You mentioned this solar car driving across the U.S. and Canada. Could you tell us a little bit more about that? It sounds interesting.
Oh, yeah. So that was a very fun project back in college. Back then there was the American Solar Car Challenge, and that it since has kind of died away. The Department of Energy was the big sponsor of it, and I think they eventually moved on. But yeah, we several different colleges would, I think there's about 25 colleges that would build a solar powered car and race it. And I was on we had mechanical and electrical teams, so I was more on the electrical team. But yeah, we built a lithium ion battery pack, a solar array, and then we used low end PIC microcontrollers to talk to everything. So we'd have to talk to a motor controller over serial, and we had a driver display, like an LCD. I don't know, it's like a 4-line by 20 character display or something like that.
Oh yeah.
Talk to that over, I think that was UART or SPI or something, and then have to do a lot of ADC work to monitor the battery pack and make sure we weren't overcharging or undercharging our battery cells and stuff like that. It was very fun. We also, I guess we talked over a serial port to a radio that could send telemetry data to a team laptop that was following in a chase vehicle. And so you built the car. In our case, it was mostly like Kevlar and carbon fiber vehicle and stuff, and then we'd race it on mostly highways. We tried to stay off the interstates too much because the cars, they certainly can go 70, 80 miles an hour, but most of the time you're cruising more like 40, 50, maybe 60 miles an hour. And so and also the smaller highways are good because they occasionally do media stops, 2 or 3 media stops a day in the small towns along the race route, and people would come out and see the cars and stuff like that. So it's part of the event was just to kind of gain recognition of alternative energies, solar power, stuff like that. So it was a very fun engineering challenge. Yeah.
How did you place?
So we did 2 races. One was, and they would do it every other year, so it'd take a good 2 years to build a vehicle. So with the one we did in 2003, it was from Chicago to LA, mostly along Route 66. So that was really fun.
Oh wow, yeah.
I cannot remember. I don't know. I think we were in. I can't remember if we were in the top. I think we were somewhere in the top 10. I don't know. And then the second race, it was from. Where did we start? Somewhere down in Texas, and then it went up to Canada, and then across to Calgary.
Wow.
And that one was really fun.
Those are long trips.
It was very and also being in a solar car, you only really drive when it's sunny out. So you drive from like 8 a.m. to 5 p.m. or so, and then you'd kind of pull off and try to angle the solar array up at the sun as it sets and stuff, and try to charge your batteries as much as you can. So the overall trip would be about 10 days or so, something like that for the full race. They'd have a couple of points where they'd let everyone catch back up. So they'd say, for this second leg, we will stop at I think one of them might have been Raleigh, Missouri, and if you got there early enough, you'd have a full day there, and otherwise you might only be there for a few hours or something to get caught up. But it was a very, very fun experience. I'm glad I had that opportunity.
How much could it charge itself while, okay, what am I trying to say? If you had a perfect sun, was it enough solar power to drive the car, or were you still draining the batteries during that time?
Yeah, no, in perfect sun, you could charge a little bit while you're driving, depending on your speed.
Charge while driving, okay.
Yeah, depending on your speed and if you're going up a hill or something like that. And perfect sun, and also a lot of it depends on the quality of your solar array. good quality space grade solar cells are really expensive, and so yeah, depending on how many sponsors you could find for your team and stuff like that, then yeah, you might have more or less success at charging while you're driving, but yeah, and also it really depends on the time of the day. So at noon, where the sun is straight overhead, and depending on the direction of your travel, north south versus east west or such. But if the sun's straight overhead, then you're generating more power than 8 in the morning, 5 at night, where the sun's off at a 20-degree angle or something like that, and then you're not generating nearly as much power. So yeah, there's lots of factors to it.
Cool. Okay. Is there anything else you want to go over today, Brad, before we let you go?
I don't think there's a whole lot else to chat about. Yeah, Garmin. I'll give the usual plug that my team's not hiring right now, but Garmin as a company is a big company. We're always hiring, and we got a lot of our work is done in the Kansas City area, but we have got branch offices globally through lots of places internationally. So if these sorts of problems sound interesting to you, then certainly pull up Garmin's webpage and look around. I have a lot of fun working on these problems where especially seeing how much we can fit into a very small amount of memory. But if that doesn't sound fun to you, we also we do automotive devices and marine devices and aviation devices, and Garmin's a very diverse company, and those don't always have the same trying to fit things in problem. They have other problems of lots of fun stuff to work on, and so.
Yeah, I'd imagine an aviation or marine device, it's practically a PC compared to what you're working on.
It absolutely is, yeah.
Yeah.
Basically a PC, yeah. Aviation is interesting too, that they were similar to fitness for a while, that they are all, I believe they're all C, but for different reasons. Fitness was all C historically because of all of our RAM and ROM limitations and concerns,
Yeah.
but on the aviation side, they have to do a lot of FAA certification type stuff, and I'm not familiar with that, but my understanding is that it's a lot easier to get certified in C, where you can very easily tie a line of code to assembly that gets generated, whereas in C++ you might not realize that you're calling implicit constructors and stuff that are generating thousands of lines of assembly for you under the covers. And so I think it's just interesting. I think aviation is still pretty strictly a C shop as well.
Interesting. Yeah.
Okay. Well, it's been great having you on the show today, Brad.
Yeah, it's been great chatting with you guys. Thanks so much.
Thanks for coming on.